Hi, my name is Miguel and this is Techno Digital School. In this video I will not be talking about finite element simulations nor abacus. Instead, I will explain step by step how to set up a Python 3 environment for scientific applications. Whether you already use Python and maybe you're struggling to fix incompatibilities with the packages that you need, or maybe you have just got into it and you're not sure where to start, this video is for you. We will see that it's very easy to set up Python once you learn the basics. So let's go. The first thing we need is to have a basic understanding of how Python works. In a sense, when we run a Python program or a Python script, we call a Python interpreter that somehow executes the commands inside and performs whatever actions. This Python interpreter lives inside an environment that contains libraries that we can use for different purposes, like data science, mathematical operations, image processing, video game programming, making plots, machine learning, and many other tasks. So to use Python, we can install one of these big environments with all these libraries. This is usually done by installing a Python distribution like Anaconda. So whenever we run any Python code, we will use this unique environment. This is a one solution for all, but it has some disadvantages. The first is space. These environments take several gigabytes of space and contain many libraries that we may never use, actually. For instance, Anaconda installs hundreds of additional libraries, I think it's 250, and occupies more than 5 gigabytes. The second disadvantage is compatibility. We may find compatibility issues between libraries that we want to use, or even with the Python version. Let's say that we have some legacy code that runs in Python 2.7. However, 99% of the Python programs that we use nowadays are in Python 3, and there are some important incompatibilities between them. So we would need two separate Python environments for Python 2.7 and Python 3. And the third disadvantage is don't put all the eggs in the same basket. Yes, don't trust all your Python projects to a unique Python environment. These are not invulnerable, and they might get corrupted when updating some libraries or for many other reasons. The strategy that I recommend, and I've been using myself for many years, is to have independent Python environments for different purposes. Having separate environments means that they can have any Python version, 3.7, 2.7, 3.10, or whichever. And these environments are lighter because we decide which packages we want or we need to install. We will use a parent environment to create each of these child environments and to select which environment we want to use in each situation. The tool to accomplish all this is called Conda. And for that, we need to install Miniconda, which is the name of this parent environment. So let's go. So we start searching in our favorite web browser, Miniconda download, and here it is. And once in the web of Miniconda, we can go down, and here is the version that we want, Miniconda 3 Windows 64 bits, because I'm using Windows. We also have some other versions down here with Python 3.9, 3.8, 3.7, but we don't really care. Any of them will be valid for us. As long as we install Miniconda, later we will be able to create any Python environment with any Python version, even older than the ones we see here. So let's come up here and download it. Once the file is downloaded, let's execute it. And here it is. Click on next. I agree. I will install it for me. And this is something that we may have to write down somewhere, just in case. Where are we going to install Miniconda? So we will write this down, or keep it in mind at least. And one more thing we see here is the space. Installing Miniconda takes less than 300 megabytes, whereas installing the full Anaconda distribution takes, I think it's more than 5 gigabytes. So click on next. This is very important here. It's better if we select the first one, add Miniconda to my path, so we will not have to add Miniconda to the path manually. In this way, we can use Conda commands directly on the command line, because we will be using the command line a lot later. So we can click there. This one is not really necessary. We can unclick it. And then we would click on install. I will not install it again because I've already installed it before. So I'll click on cancel. Yes, I want to quit. And let's go and let's see how to create this Python 3 environment. So in Windows, we will open a command line. We can do it in many ways. For instance, if we click Windows X, this shortcut, we will see here these options, and we will open the command prompt with admin rights, because we will be installing stuff. We will be installing Python packages and Python environments. So we click here. We will be using all the time Conda commands to manage all the environments. For now, you will only have one, which is the base environment, which is Miniconda. But first of all, we have to check if we can use Conda commands. So we come here and type Conda. And if you see something like this, a long message like this means that you can use Conda. Let's clear the screen with CLS. But if you type Conda and you see something like this, I will type it wrong. You see it's not recognized as an internal or external command. You will have to recall the place, the location where you installed Miniconda, and add that location to the path of Windows. In my case, Miniconda is installed in this location, see program data Miniconda 3. And in the Windows path, I have this location and also the scripts, because in scripts, there is this Conda command, conda.exe. But if you already selected the first option during installation, it should be already in the path. So there is no problem, we can use Conda now. So let's clear the screen again. And first of all, let's see what is the Python environment that we have in Miniconda. So to do that, we can make sure that we are using Miniconda by activating this environment. We can do Conda activate base. This is the base environment for Conda. And this is how we activate the base environment. And if we write now Python, we see that we have installed a Python 3.7. This is an older installation of Miniconda that I had, but in your case, it will be the same, maybe with Python 3.9 or 3.8 or 3.10 even. So let's quit Python with Ctrl+Z, and we're back in the command line. Miniconda is a very basic Python installation, so it only contains a few fundamental libraries. If you want to use a Python environment with many more libraries, I strongly recommend to create other environments. Leave Miniconda alone, only to manage all these independent environments. Let's create a new environment with Python 3.10 and some of the most used scientific libraries like NumPy, SciPy. So we go to the command line again, type Conda. Create is the command for creating new environments, -n, then the name of the Python environment, let's call it Py310, and now the libraries with the versions. So first library is Python 3.10, that's the Python version that we will install, and then the other libraries, NumPy, SciPy, Matplotlib, and if we don't specify the versions, it will install the latest versions which are compatible. So let's hit enter, and it will start collecting all the data and preparing all the installation. So these are all the packages that will be installed to make these libraries work and Python work. So yes, hit enter, and it will start downloading and installing all these packages. So let's wait for it. It will take a couple of minutes. The installation process is completed. We have finally a new Python environment. It's a 3.10 with some libraries, NumPy, SciPy. And how can we use this Python environment now? Because again, if we type Python here, we will see that it's still 3.7, the older. We are still using the base environment. This is Miniconda. This is still Miniconda. So Control C to exit. And to activate this new environment, we can see it here. To activate this environment, type Conda activate py310. So Conda activate py310, and there it is. I will clear the screen, CLS, and we see here now it's py310. So now if we type Python, we see that it's a different Python version. And in fact, now we could import NumPy, and there it is. We have access to NumPy. We could say numpy.array, for instance. Well, of course, I have to pass something to the function array. So let's say 0. Okay, we have an array with an element of value 0. Let's quit again. If we want to run a Python script now using this Python 3.10, all we have to do is to write Python and then the name of the script that needs to be in the same location. In my case, Python my folder. So the name of the script that I have is test py310. So it contains some lines that will only work and will give some particular results using Python 3.10. So I will hit it. And the first thing we see is that we're trying to run this line here. And the error message that Python 3.10 gives us is different from Python 3.9. In this case, it has some more detail, some more information about the error. Did you forget parentheses around this XY? If we fix it with X and Y in parentheses, and we run this again, now we didn't got this error, it worked. And there is one more thing, one more feature from Python 3.10 exclusive from this version, which is a matching pattern like this. So introduce X, let's say we introduce 0, 1, and this gives us Y equals 1. Is enter this match statement and select one of these cases in which it matches. But I will not go into detail in this part. So this is how we run scripts with a particular Python environment. We activate it, and once we have activated the environment, all we have to do is to write Python as usual, and then the name of the script that we want to execute. What if we want to install another library in this environment? Well, all we have to do is to type Conda, and in this case, the command is install, and then the name of the library. So let's say we want to install scikit-learn. So we say scikit-learn and enter. And that's it. If it finds the package, it will ask for confirmation again. So we can hit enter. By default is yes. That's why we have these square brackets. The default, if we don't say yes, will be yes. So we hit enter and it's done. And this is it. We have installed scikit-learn in this case. Let's say we want to install another package. I will clear the screen, and I want to install, in this case, conda install pyauto-GUI. This library is very practical if you want to automate some tasks like hitting hotkeys or programming some other behavior in your computer. So let's try to install this library as we did before. And in this case, it didn't install it. We see that it wasn't able to find this package. Package is not found by auto-GUI. It didn't find this package in these repositories, in these channels. So how do we install this package? From where can we install this package? We are looking at Anaconda repositories, which contain hundreds and even thousands of libraries. Where can we find it then? If we Google conda install pyauto-GUI, we will get to this page. And this means that this package is available in Anaconda, in one of the Anaconda repositories, but it's not one of the default ones, even though it's one of the most popular, and it's CondaForge. So how can we install a package from a particular repository? Actually, we have the command down here, conda install C for the channel, conda forge, and then the library, in this case, PyAutoGUI. So I will copy these, and back in the command line, let's clear the screen, I will paste it. And this is one way to install from a channel. And there is another way, which is instead of that C, we put 2 colons, no space. And this is the same. We're going to install PyAutoGUI from this channel, Conda Forge. So hit enter. And in this case, it will be able to find this package and install it successfully. These packages will be installed. So yes, hit enter. It found the package and there it is. We have it installed. Let's clear the screen. And before moving on, let's check which are the libraries that are installed in this Python environment. For that, all we have to do is to write conda list, and this is all the list of packages inside Py310 environment. We can see that we have installed now PyAutoGUI, should be, yeah, here it is with this version. If we go down here, we have SciPy 1.9, up here it's NumPy, Matplotlib, etc., etc. Let's deactivate this environment, conda deactivate. Okay, and we go back to Miniconda. We can now take advantage of having different environments. Let's create a Python 2.7, one of the obsolete Python versions. So for that, all we have to do is to do again, conda create, and the name will be Py27, in this case, Python equals 2.7. And I don't want to install any package for now there. So hit enter. And here we go. Yes. Everything is installed. And now we can activate this environment. Conda activate Py27, conda activate, and the name of the environment. Okay, there it is. This is Python 2.7. Let's check it. Py27, here it is. So now we could do something like print, which is something not allowed in Python 3 without parentheses, and it works. So yes, it's Python 2.7, it's real Python 2.7. Okay, let's close it. I will deactivate it and show you how to delete, how to remove an environment. So I will say conda deactivate. There we go, base again. And to remove an environment completely, all we have to do is conda remove the name of the environment, Py27, and now -- all. And this will remove completely all the packages inside the environment. Yes, and the environment as well. That's it. How can we make sure that the environment has been deleted? We can get a list of all the environments that we have. And this is with this command, conda info -- envs for environments. Like this, we get all the environments that we have. In your case, you may only have the Python 3.10 and the base environment. This command is very useful because it gives us all the names of the environments and where are they installed. The base environment is here, the Miniconda environment is here, and this is Python 3.10, which is here as well, similar. As you can see, I have many more environments, although I use 2 or 3 of them most often. The rest are for trials or testing different libraries that I have found interesting. In this way, I keep the environments that I use most often as clean as I can. This is a lot easier to maintain than having a huge environment with the advantage of having any Python version. And that's it. You know all what's needed to start using any Python library with any Python version. See you soon.